Pedro Saleiro, pleasure to be here. We tried to reach out to you last year. You were abroad, you can be here.
I replied.
No, I know that, I know that. You can be with us, and we truly wanted to because you've been into the ethical aspect of it all, AI, etc. And you've done a terrific research and other sort of tasks, job in this topic. We were going to have you in the afternoon. Unfortunately, Pedro cannot be with us in the afternoon, so we changed last night the agenda. So Pedro is going to take it from here, and then we're going to go for lunch. Thank you once again. You please present yourself. That's where you move forward. There you go. Thank you.
Okay, thank you. I must confess that I'm feeling a little bit in a tough position because I'm the only obstacle between you and lunch right now. But I think I can get you a few minutes of your attention. So here you can see a few examples of decision-making tasks in which AI is being used to replace or complement the human decision maker. And this is really great. We are getting faster and better decision making. I'm going to dive a little bit in one of the projects that I worked at University of Chicago during my postdoc at the Center for Data Science and Public Policy, which is a partner of the Data Science Knowledge Center here at Nova SPE. And here we can see an example of a preventive healthcare project, where we had the chance to have access to 1 million electronic health records of patients in south side of Chicago. I don't know if you are aware, but south side of Chicago is predominantly populated with people from lower socioeconomic backgrounds. And Alliance Chicago, our partner in this project, they are a network of health centers, more than 60 health centers, and they challenge us with this problem of trying to predict the risk of developing diabetes even before you get diagnosed with the disease. And the goal here was we use these 1 million electronic health records. We built a machine learning model for risk assessment using binary classification. And then when the patient comes to see the doctor, regardless of the specialty of the doctor, usually then there they get weight and they take other vital signs from the patients, and the medical doctor can update the risk of the patient right away. And by doing this, the doctor can redirect the patients to specific services, to specific care, and hopefully to result in better outcomes for this very endangered population that often don't have access to other types of care. Here, another very interesting example of a project that we worked on. It was the first time that we got access to a combination of all touch points of a citizen with the public services. We partnered with Johnson County in Kansas, and they provided us access to data from public health, from police, from the criminal justice, from the courtrooms, from mental health services, from a very different set of services. And we could create something like this. This is actually a real example of one person that interacted with all these services throughout the years. And you can see that they have several calls to the 911, the EMS, emergency medical system. They got a few bookings, jail bookings, and they also have some cases of mental health issues. And the idea here is to predict the likelihood of people with mental health issues in the past, with a history of mental health issues, the likelihood of them getting a booking in the next year, a jail booking. In the US, often if you, for instance, you are having a mental health breakdown and you, for instance, you punch someone, you are running naked on the streets, you don't get diverted to mental health services. You get a jail booking and you spend the night in jail. And these people that are often dealing with crisis, and jail is not really the right solution for their problems in that moment. And Johnson County is really pioneer on that. They're developing programs of mental health assistance where a mental health provider would go along with the police when there are calls for specific codes related with substance abuse, suicide calls, and everything related with the mental health crisis. And the idea is to really help the people to stabilize, and then maybe they can go to a specific mental health facility. And here, we are trying to shift a little bit that. That approach is reactive. We want to be proactive. Even before someone gets a mental health crisis, we want to provide them access to mental health services in order to avoid even the people making something dangerous to them and to other people in society. And you might be thinking, oh, this is somehow similar to Minority Report. We are trying to kind of doing something kind of predictive policing, trying to figure out if someone will get arrested in the next year, even before they have done something. But the good news is that police doesn't have access to the prediction. The only partner and the only entity that gets access to the full data and the prediction is the mental health services. And the intervention is about mental health services. And this is really great. The cases of the unemployment project here is very similar to this kind of predictive risk projects in order to be proactive in trying to really tailor the best interventions to the people that are most at need. But as every type of decision making, we are actually making a call. When you are hiring someone, you are making a decision and you believe that outcome will be this person will be a huge added value to the company, it's going to be very successful, but you are not really sure. You are making a call. And the same happens with AI. Even if we say, and that's true, that we're getting faster decision-making and better in overall performance, we'll always have errors. Especially in decision-making, we'll have false positives and false negative errors. And then there is this thing called bias. And bias in this context of decision-making is about making systematic errors for specific subgroups of the population. Imagine that you are actually making wrong calls about hiring female candidates much more often than male candidates. You're actually being unfair towards female candidates. And there are many sources of bias, starting with the world and people. We are all biased. But then when we start building these models, we use data. And the way we process and collect that data, the sample that we are using, sometimes we are building a model on a sample that is of a population that is very different of the target population where we are going to use the model. Even the labels that we get, data scientists often take for granted that the label is actually the completely real, true outcome of the past. And what really happens is that even the labeling processing can be biased. We can think about over-policing specific neighborhoods, and that actually happens in the US. If you think about the way of you get labels in the past of success in the company, if that measure of success that you are using to label your historical cases in your company might be biased, someone said, oh, this candidate, I remember him from 10 years ago, it was really great. But this is not really objective. And another source of bias is for sure the data science, the machine learning pipeline. So every single step of the machine learning pipeline, the data scientist and the data engineer and machine learning engineer is making a decision. Is deciding to impute missing values in a given way, is deciding to create features in a different way, is fine-tuning the model, the algorithms that they decide to use, even because of business constraints, because we cannot have in place mechanisms to deploy deep learning. Let's use gradient boosting. But even these implicit choices are introducing some sort of bias. And at the end, there is also a huge source of bias, which is the human. There is making the final call, it gets the model recommendations of the score as the IFP case, but it can override the decision, the recommendation of the model. And it's good that it can do so because often the model is wrong. As I said before, there are false positive and false negative errors. And the goal is that the whole system, the model and the human taking decision to be less biased and have higher performance. Actually, I just went back. And here are a few examples of recent news articles about, in this case, I bias, kind of get a sample of Google, Facebook, and Amazon. And some news articles that surfaced, news stories about bias in their new predictive tools or in translation, or there is a recent article about Facebook showing specific ads for jobs just for men and not for women. And we can think that that's really bad because, you know, the company might say, oh, I get 90% of candidates that were male. But the women didn't know about the job at all. So, you know, you can, this job advertising thing is kind of tricky. But nothing of this is illegal. There is no legislation about what ads you should show to someone or forbid you to show in specific ads for men or women, or African Americans or Latinos. There is no legislation. It's legal. And after all, the companies, what they really want is profit. But it's time to starting to think about reputation costs, about the branding, about the impact of the companies in society. The three cases I showed, they are really big companies. This is really like a specific news stories that will be there, but after a few weeks, people are so entangled with these ecosystems of Google, Facebook, Uber, whatever, they will keep using it, or most of the people. But if you are a small startup, and there is a news stories about this AI software that are developing, and some journalists found, thankfully, that your system is biased, maybe the reputation cost is too high. And even you might be even in a difficult time to capture talent, for instance, if you are openly known for being biased and developing biased products. So I'm a tech guy, as you can see by my outfit. It's not about these data scientists and software engineers to make the call of which values the product should encode. It's about leadership, to have a clear vision of what they stand for. Think about Tesla. Tesla is not developing the fastest car, the most comfortable one. There are other competitors there. Their core mission is about moving to a sustainable way of moving around people that is eco-friendly. Maybe companies might start to think about the ethical values they want to encode in their products as a value proposition, and I believe the market will like it. But at the same time, regulation will come. You can be sure about that. GDPR is just a start. And if you want to be really stressed out again about new regulation that is coming and you're not prepared for that, maybe you start thinking about new fields where regulation is coming. And maybe you need to start thinking about these ethical issues. And about regulation, fairness is normative. And there is no universal definition of what means to be fair. So it's really about thinking about the application, the context where your AI product will be put in place, the types of decisions, the impacts it has on people, and then you can start deconstruct and thinking about what types of bias do I really care about. Maybe I don't care about all the biases. Maybe if I'm providing benefit to someone, maybe I care about missing people that really need help. If I'm, on the other hand, the intervention is kind of a punitive, maybe I care more about different types of biases. And there is exception though. If you are developing software, if you are a consulting company, if you are working for the government and for the public sector, then the game is a little bit different. Because governments should really care about, inequalities, about fairness, because often the services that the public is using, they don't have other choice. And even if they have, maybe it's a really, really high-cost choice. So if you think about this example of the Compass news story of ProPublica, of the criminal justice system in US, was using an algorithm to decide the bail amount on pre-trials. The citizens, they don't have any alternative to, I prefer to use that courtroom there because I know that the software is okay, instead of using that one. So when you're developing software for governments, be really mindful about the real impact of, even before regulation, the impact of what you are doing and what you are really delivering to the government. And we really believe that audit for bias and fairness is really the first step towards mitigation. It's the cliche, the really old school cliche of you cannot measure, you cannot improve it. So let's really start with that. That's why we developed Akitas. And you heard about the example of the Nova SPE project of in the implement. They're already using this. This is an open source, free to use for both research and commercial purposes. You can use this for free in your products. And basically, what can you do with Akitas? Akitas will break down the predictions for different subgroups, and you will be able to compare the errors across these different groups. And you can use it using a web audit tool, which was designed more thinking about the policymaker, non-technical kind of stakeholder, where you can actually install in your own infrastructure this website, and people can use it. They will upload data, and they will get a bias report about your algorithm. You can use a Python library. So if you use Jupyter notebooks and you like to import, or your team is using Jupyter notebooks, this is as simple as pip install Akitas, import Akitas, and you can start using it. Or you can use the CLI if you want to kind of run Akitas on batch. You have your database with predictions, and you want to audit all of your thousands of models just at once, and you can run it as well. And this is for free. And one of the key applications of Akitas is when the teams are doing model selection. This is kind of an illustrative example. Nobody actually makes these plots, but for you to get an idea. If you just care about your global performance metric, like recall, regardless of the groups of your data, you are picking a model that will go to production. Probably you'd pick the yellow one. After all, you want to maximize your global performance. After running Akitas, you unfold a new dimension. And now maybe, instead of picking the yellow one, you can compromise a little bit the global performance, and you can pick a model that is way less biased than the one that you would pick if you were not aware of the biases of your models. And as I was saying before, fairness and making decisions about fairness is all about the context and the application. So usually in decision making, you either are, providing some kind of intervention that is punitive in the case of criminal justice, or if you think of even it can be a benefit or punitive, but really depends on stakeholders. So in case of a job application, the people that get accepted, you are providing a benefit. The people that are not getting accepted are actually missing an opportunity. So if your intervention is punitive, you really care about false positives. So it's really about, you don't want to hurt people that really don't deserve it. And if you are helping people, you care about missing people that need help or would benefit from the prediction of diabetes to get access to tailored, personalized services, healthcare care. Then you care about missing people disproportionately across groups. And how it works. Basically, you just need prediction scores and labels. Then you use a set of attributes that you care about to audit for bias. So if you think about, in your context, it makes sense to think about gender, age, race, and so on. Even if you didn't use in your model, for building a model, you can use it for auditing, because you just care about which kind of attributes each one, if it's a man or a woman. Let's see if the errors are matching or not. And you need to pick a metric, once again based on the context, and then you get the report. And then you can break down the results by different metrics and different subgroups. In this case, it's just by race. You can break down by every single categorical value of the race attribute. You can plug Tableau, which is really cool and easy. You don't have an excuse to not look at this, right? And you can look around and you can see the different values for these metrics. And there is a lot this misconception about, if I want to be fair, why I can just remove race from my data, right? If I don't use race, how the model will be able to discriminate based on race? Well, that's possibly one of the wrong, or most wrong assumptions that people have in this area. Because often there are other attributes that really subsum the race attribute. If, for instance, in US, education level, the zip code, you know, in the year of the first booking that people got, all of these are correlated. If you think about browsing history of men are different of browsing history of women. All these different attributes can be correlated with the ones. So don't simply think that by removing race or gender from your models, you are safe. So that's it. Thank you.
Pedro.